All right, ladies and gentlemen, today we're going to be going over the momentum of a system worksheet. Now, this is a pretty tough worksheet overall because we're dealing with a lot of fairly complicated momentum problems. We got a lot of moving pieces. Now, momentum as a whole, the math behind it, the actual algebra and stuff is pretty simple. The tough part is setting up the equation correctly. And it's, of course, figuring out what they're trying to ask, which is particularly tough in this worksheet because they ask a lot of different things and it's easy to get confused between what they're asking for. So let me walk you through how to do this worksheet, and hopefully we'll get some good understanding after that. I do want to keep in mind that we're going to be doing more practice with momentum. This isn't kind of our end-all be-all. So don't worry if you don't quite get it by the end of working on this worksheet. All right, so let's start with question 1. So a very wordy question overall, but kind of the key parts is that we have a blue cart that is traveling. We have a blue cart that's traveling to the west and has a momentum of 2, and a red cart that's traveling to the east and has a momentum of 3 kilograms per second. And it's asking the total momentum after they collide. Well, because the momentum after they collide is the same as before they collide, you just need to find the momentum before they collide. And like I said, that's one of the tough parts about momentum, is dealing with that formula. It's a very simple formula right now, P before equals P after, but sometimes the concepts can be hard to get. So I just need to find the momentum before, and I know the momentum's after. Well, I have both of the pieces. I have 2 and I have 3, and I know they're going in opposite directions, so they're going to subtract. So I'm left with 1 kilogram meters per second. And that would actually be 1 kilograms meters per second to the east. All right. Question 2. We have a car that's moving in, and it's hitting a car that has the same mass that's at rest. So we have car coming in, hitting car at rest, and then afterwards they stick together. So my momentum before is equal to my momentum after. My momentum before is 0.5 because it's 1 times 0.5, which is 0.5 kilograms meters per second. So that needs to be my momentum after. However, my mass is effectively doubled, which means my speed, I'm dividing this by 2 because my mass is doubled, to get a speed of 0.25 meters per second. So again, I have my momentum before is 0.5 because this has no momentum and this has the mass of 1 and the speed of 0.5. My momentum after is mass times velocity. My mass is 2 kilograms because the two objects are now combined, times the speed that I'm looking for. So I just need to divide that by the momentum. So 0.5 divided by 2 is equal to that 0.25. All right. So next one is a show your work type of question. We're trying to find the total momentum of the 2-ball collision after, the 2-ball system after the collision. Now, it's the same as, again, before the collision. So we just need to figure out what the momentum before the collision is. And that's as simple as multiplying and adding the two numbers up. So 6.28 times 0.25. You know, I should add units to this, just to make sure we kind of have it correct. 6.28 kilograms times the 8.5 meters per second, plus the 5.45 kilograms. And let me just double check the directions. Looks like the first bowling ball is traveling to the east while the other one's traveling to the west. So we have opposite directions, so I can make this speed a negative speed. And it's going to be negative 10 meters per second. When I do this math out, I get 61.88 kilogram meters per second minus 54.5 kilogram meters per second, which gives me a total answer of 7.38 kilograms meters per second. Sorry, my nose is a little runny for whatever reason. But that is my answer right there. All right, question 4. Question 4 is an inertia question. Again, anytime you see the inertia, just switch it out for the word mass. So they definitely don't have the same masses of each other. I can see car A has a mass of 2 and car B has a mass of 3. So they definitely don't have the same inertia. Car B definitely has the greater inertia. Their momentums, however, are the same because mass times velocity, it's 2 times 3, 3 times 2. They're both 6. Okay, this one. I apologize. Anytime you see this kind of thing, that's a my bad right there. I apologize for that. It's supposed to be 10 to the third. The superscript just didn't work. So the 1.1 times 10 to the third collides head-on with a van having 2.5 times 10 to the third meters per second. And after the collision, they lock together and immediately come to rest. So what that means is the momentum after is 0 because afterwards they're at rest. So the momentum before also needs to be 0. And because they're 0, it means when the two cars have to be the same momentum as each other when they hit each other because they're going in from the two sides. So the momentum of one of them has to equal the momentum of the other. And we know the momentum of one of them. We know the momentum of the van by just doing mass times velocity. P is mass times velocity. My mass is 0.25 times 10 to the third times 8 meters per second, which gives me a total momentum of 20,000 kilogram meters per second. And that has to be the same as the momentum of the car. So I'm going to take that value. And again, they need to be the same, so they cancel each other out. And when they hit each other, they're going to go at rest. Divided by the mass, which is 1.1 times 10 to the third kilograms, which gives me a total speed of 18.2 meters per second. And it's a pretty logical number. That's a little bit less than highway speed, which makes sense. All right, question 6, I'm going to wait to the end because I think this is the toughest question on here. Elastic collisions tend to be. So we're going to come back to question 6. Okay, question 7. So question 7, we have the two things colliding with each other. They're bouncing off of each other. What is the total momentum of the car? Well, there's some great numbers in there, but all that doesn't matter because I know the momentum before and the after need to be the same. That's all I need to know. I like this question a lot, question 8. So question 8 has all this stuff that we're focusing on, this momentum before and after stuff, this momentum of a system stuff. But what's nice about it is it's purely visual, and I don't know why. I really like this question. So the two momentums are going to get added to each other. So we're adding these two arrows to each other. So the original arrow length is this long, which looks like it corresponds to 4, but we also have to add this tiny little bit to it too, which means that my overall answer, well, to the right wins, so it's going to be choice 2 or choice 4, and slightly less than the first one, which looks like it's choice 2. Okay, question 9. Question 9 is a challenge question. And it's definitely a challenging question overall. It's pretty rare these days to see where they're asking you to figure out the notation of something. We often, these days, we just talk about numbers. But let's do the notation here. So the momentum before has to equal momentum after. Before has to equal the momentum after. The momentum before is just the velocity times the mass A, because mass B isn't moving, so that's just going to be 0, is equal to, and now that they've combined together, it's mass A plus mass B, because they're combined, is my momentum after, times my new speed V prime. That little dot, or that little slash means prime. It's just a good thing to show that, hey, it's changed. That's just a kind of a common notation that we see. So we are solving for V prime, which means you need to divide both sides by this, so we get VMA divided by MA plus MB is equal to V prime, which looks like it's choice 4. So it's the same stuff that you've done, just without numbers, which can often confuse people. Let's go up to 6. As I said, 6 is probably has the most going on. So we have to first figure out the momentum before. Well, the momentum of this car before is 32. 8 times 4. Momentum of this car is 24. 6 times 4. Which means that my momentum beforehand is 8 kilogram meters per second when I add these two going to the right. So that's what my momentum before, which means that my momentum after has to equal 8 kilogram meters per second, which is equal to now the sum of the two momentums after. So this is to the right. So I'm going to make to the right positive in this case. To the right positive, which means I'm just going to make that little guy negative. And I'm going to keep that convention throughout. And the reason why I'm paying extra attention is because I see that the answers have right or left. So I want to really make sure I get the correct direction out of this. So I'm going to say to the right is positive. So 8 kilograms per meter per second before is the same as after. It's positive because it's moving to the right. Now the 4 kilogram car after is also moving to the right. It has 4 kilograms, it's moving at 3 meters per second, which means its momentum is 12, 4 times 3, and it's also to the right. Plus my momentum of the other car, which is 8 times the velocity that I'm looking for. And my goal is to figure that out, is to find what that velocity is. Well, I subtract both sides by 12, and I get negative 4 kilograms meters per second is equal to 8, I'm sorry I didn't put the units there, 8 kilograms times V. Divide both sides and I get negative 0.5 meters per second. And as I said, positives to the right, negatives to the left. So this car is going to come in and it's going to bounce off of the other car, move much slower, while the other car is going to end up changing its direction completely and going to the right. All right, I think that's every question on here. As I said, this is a lot, and we're going to be doing more practice with it. If you do need any more help with these, feel free to ask. I'll definitely help you out. But that's everything for this video, and I'll see you guys later.